Hello, today we're going to demonstrate that how to create a truss structure supported by a multi-story building that under it. So to demonstrate this one, what we're going to do is that we can have a look at one of the toolbox provided by myself in Excel, which can generate the coordinates. Then you can copy and import all the coordinates into the Autodesk robot and then to create the structures, or the other way you can use the software I gave it to you with the function that can generate the truss structures directly into the Autodesk robot, and then which way either way will be okay for you guys to generate the structures. So please have a look at the structures. So what we have is that we have a 5-meter bay for each bin, and a 6-meter from one column to another in the other directions, and we assume the truss structures are 2 ring only, so was 2 bay connect to the top of the multi-story building. And then in these structures that all the beams on the both sides shown here are subject to a Q dead load and live load as well, is given in this problem statement. And then the point load, which should be the simulating the wind load, is applied to one side of the building, and then the top 2 layers are much bigger than the bottom layer. So between these 2 buildings there was 160-meter space to be covered by the truss structures. So to be for the convenience of demonstration, so we simplify this model to 1 bay only. Theoretically, in this type of building, it possibly get quite long in the other direction. So this is not only 2 lane, possibly cover maybe 30-40 meters long. But you can do this one as long as you know how to do 1 bay. So the rest of it should be quite easy to copy and paste to create the other part of the structures. So let's have a look at how we create this one. So to do that, we need the Excel file, which has uploaded to the Moodle already. You can download from the Moodle. And in these structures, and then you can input into the structures, and then the dimensions accordingly. Say for example in here, what we have is that let's assume that we have decided we're going to give a 20 dot so 20 divides from this in this arc, so we got a 20 base inside. And then the y direction we have 2 bays only, so 1 and 2, so 3 meter each, so 3 meter each here. And the connections between this one, as we said, is already given, is 60 meters, so we put it key in the information. So the radius of the cell that so will give you the chunks decide that how big that your arc going to be. So the bigger value you put in, the shallow the shell it is, and then the smaller, then you possibly get a higher that arc in here. But however, pay attention to that. You need to make sure this number has to be that bigger than half of this one, otherwise it won't be able to generate a shell, cover this enough space. And the thickness of the shell, normally we put in that a value which allow that all the connections, 4 bar connected in the middle, create the maximum angles. So here let's assume 2.8 meter. That was good enough dimensions to create this one. So after we finish this part, what we can do is that we can ask the computer. Let me delete this data first. So ask the computer to generate these data, and then in this shell here. So if I click on generate the 3D cylindrical shell data, so all the data is going to be here. So all the node coordinates and all the bar connectivities is shown here. So what we need to do is that we only need to do to bring up the Autodesk robot. So take a while to finish. So give a few minutes to let it load up. So once we start, to make sure that when you start, you have to make sure the structures you put in has to be that 3D frame structures. You need to use this one, but don't use this one, because if you use this one, you build the frame structures, you cannot put the uniform distribute load onto the structures. So that's a drawback. So because we have frame structures and truss structures together, so we have to use that frame 3D design and this type of the model to create the structures. So let's click on this one. So once we get in here, what we need to do is that we need to create the nodes that which you can directly copy from the structure. Say for example, you can change to the node that the layout, and then here is the coordinates we need to copy in. So let's switch to the Excel, and then remember only copy 1 X, Y, and Z, but don't copy 1. Okay, so let's copy these 3 to the bottom, very bottom of the data. Okay, so now we copy the coordinates, which is, but remember, don't copy this one, just copy this 3 X, Y, Z, and then copy all the datas. And remember, all these datas are now in millimeters. Okay, so once finished, we copy this one, and then we click on right click on here and choose the copy. And then all this data has been copied into the clipboard. And so once we come back to the Autodesk robot, and then what you need to do is that you need to maybe select these 3, and then when you select this 3, look at this one, this is in meter, so we need to change the units by click on the meters here, and then the unit, so and then dimensions, and then structural dimension need to change to the millimeters first. So make sure it's millimeter, and then close OK. So once change millimeter, you see all this one is now is in millimeter. So you can right click in here and then paste into it. So you see, once you place on this one, actually that the truss, the node has been generated in here already. So you should be able to zoom in by holding the shift key, and then in the middle scroll buttons of your mouse, hold on both, and then can spin the structure to have a look. And possibly the numbers here not good to view in these structures. You can disable it by click on this one. So click on this one, so you see that that's the structures, that's the node we have created. Okay. So we can also generate the bar. So by change the bar layout, and then you come back to Excel and just click choose all the coordinates here, and then if you click on copy C, or maybe use the copy in here, and come back to Autodesk robot, and make sure you select this tool, and after that right click on here, and then click on paste. So that's the truss structures that you generate. So you hold on the shift key, and then hold on the middle button of your mouse is a wheel, and then you can hold on both, and then you can spin the structure to have a look. That's the truss we just created. Okay, this is one way to create the structures, and then the other way you can let me close this one, and then I don't need this part, so I just close these structures. So the other way you can do is that to save your hassle to copy and paste, what you can do is that you can also use the create 3D cylindrical shell to Autodesk robot directly. So if you're setting up the coordinates, this one, and then the datas properly, what you can do is that you can use this one to create the truss structures in Autodesk robot directly. So see, there was no robot now starting in the my computer at the moment. So if I click on this one, you see the Excel going to run the Autodesk robot in the background. So you see now it started up the Autodesk robot, and after a while, and then you can open up this one. You see the truss still may be creating, so it hasn't finished yet. So once it's finished, then you should be able to see that the flashing stopped, and then you come back here. So this is back to normal already. Then the structures should have been generated in this one. So if you click on the zoom all, and then you can use hold your shift key and hold your middle key of your middle button of your mouse, and you can look at the structures. Okay, this is the structures you have generated. So by doing this one, you see the Autodesk automatically that fill in all the informations you got in here, so directly. So what we need to do is that to generate these coordinates later on, we possibly need to create proper dimensions, and then also that assign this bar to simple bar for these structures. So we're going to do this one later on. So if we have a look at the details of the bar we create in here, so after you change to the bar layout from here, so we change the bar layout. So you have a look at this one. You see that the type of this one has been has been changed to the different layout. Let me convert it back to here. So you see the type of the bar has been changed to the simple bar. So that's great, because the simple bar only have the tension and compression. So we need to set up the materials and section as well. So to do that one, what we're going to do is that we need to use the proper layout from here. So we use the section of materials. So once we got this part, what we need to do is that we need to create proper dimensions for this one. So let's have a look at what we have for this type of structures. So this type of structures, as we can see there, we are using the 139.7 times 10 millimeter bar in here. So we possibly already have here, but if you don't have, what we need to do is that you need to click on this one, new sections, this button, and then they allow you to choose the proper one. So we use a circular hollow section, so that's one we have. So we're using the 317 times 10, so this is the one we have, and then double check this is still we're going to use. And then if you click on add, and then it tell you okay, already exists, which we already picked up before. But for our case here, you just click on would you like to modify? Yes, just click on yes. So all the structures has been assigned. After that, you can close this window. So once you close the window, actually, if you can highlight this one, then you can assign the cross section to this one by one. That will be too tedious if you do one by one. So the best way we can do is that you can right click in here and then choose the select, and then just select all of them. And then when you come back to this button, you see that's already highlighted. So it's going to apply to number 1 bar B and bar 1 to 320. So if you just simply click on apply, and then so all these structures has been applied to these cross sections. So if you would like to have a look at what it looks like, so you can click on this button, and then you can zoom in to have a look. So that's all. The structures has been assigned properly with these structures. So we get the truss structures finished already, but we need to create the tower under it to support the truss structures. So to do that one, what we need to do is that have a look at the structure we have in here. So one is 5 meters, the other one is 6 meters along this direction. And so that's why what we need to do is that we need to come back here. And so let's come back to starting point, and oh, somebody is calling me. Just 1 minute. I stopped the training. So we now need to continue our construction on the tower under it. So let's have a look at the details of the structures. We have 5 meters and 6 meters. So and then 4-story up. So we just need to create the grid line which allow us to draw this one that easily. So let's come back to Autodesk Robot. So we use these axis definitions. You click on this one. So in X directions, because we are constructing something in here, as we mentioned before, the center of the joint is in here, which is the center of the arc, and then that was the 0, the original point from here. So the X in this direction will be that from here will be 30 meters to this point, and then 5 meters to the first column. So we need to put in negative 35 meters. And then what we have in here, the second one in this direction is that we need to change this that repeat to only 1, and then the distance is to 5 meters. And after that we just click on add, so we create 2 axes. So y directions will be the same. We have 1 repeat, and then however going to be that 6 meters each, and then click on add. So this one is created. And then once we finish this one, what we're going to do is that we going to put in the Z direction. So Z direction, you have a 4 repeat and then 3 meter each. So after that we click on add. Then that's all the grid system has been generated. So once we click on apply, and then we're going to have this coordinate system set up in here. So and then we can close and have a look at this one by change the directions of it. So we can change to the direction where it is convenient for you to draw the bin up. So after finish, and then we can change to the bar view and then start to create the tower. So to create the tower, we need to maybe have a look at that the dimensions of the H bin. So so let's draw the column first. Column is these dimensions we're going to have. So let's come back to here. So we can need to change this one to column, and then we need to make sure we choose the proper cross section by changing this one to universal column, and is the 305, 305, 240. That's the one we are picking up. So if you click on add, it will tell you okay, already exists. So we just click on yes, I want to modify it. Then so after that, close this window, and then make sure that so make sure that say the cursor is in select mode. So make sure you come back to bar mode and then join mode. So by activating this window, and then when you come back, your cursor has been changed. So now you are in join mode. So let's draw the 4 columns, that section by section. To do that, we can maybe easier to use the drag mode. So click on drag as well. So we start from the first node. So first one. So first one, start from here, and then second one to here, to here, to here, and to here. Okay. So once finished the first column, press ESC, and then we start to draw the second one from here. Okay. So the second column, the third column. And then the last one from here, and second level to this one, and to this one, and to this one, and to this one. So that's 4 columns has been set up properly. Then what we need to do, we need to draw the beam. So draw the beam, we need to change this one to beam, and then the beam we are using is that the 356 171 57. So we should choose from here that this one convert, so this one change to the universal beam, and then so 356, and then times 171 57. So this is the one, and you click on add. So this bin has been generated into the section property table. Then again, we need to make sure this one has been activated. So we can draw this bin one by one. So from first floor. Oh, sorry, that was the first one is wrong. So we need to press ESC to cancel this join. So the first node has to be the one in here, and then to here, to here, to here, to here. Oh, I think we just found out that the first one is wrong. So the colon is the circular hollow section. So maybe we make a mistake there. So let's maybe come back here to change this one to proper one. So by clicking the section property table, and then to make sure we use a universal colon, which is the one 305, 305. Yes, so that's the one we have, and then we apply it to this several one. So that's so this has been done. So let's come back to the bar mode, and which we continue of our bin join. So double check the cross section is still the same. So then we can continue to draw the columns and bins. So once finished, press ESC. And then ESC key again, and draw the top one. So that's one tower done. So we can zoom in a little bit. Then what we need to do is that the best way to copy this one is that it's better to put the support in first. Then let's come back to the support, and then the support we're going to put in is a pin support. So we highlight this one and then pin to this 4. So we put the support to the colon N. And then after that, what we can do is that we can come back to the starting mode, which is that all the structure has been set up already properly here. And then what we can do is that we can use the edit here, and then select the copy and move. So we possibly need to copy this time, and then to the 65 meter away from this one. So we put in 65 and .0.0 and execute it. Oh, there was no structure has been selected. So what we need to do is that that's wrong. So we need to undo it. So this one has not been copied. So we need to select this one instead of the whole structures. Then we copy in this one. Just click on execute. So the other building has been added already. Now once we have done this one, then we can close this window, and you see all the structures, basic structure has been set up already. Then the next one, what we're trying to do is that we're going to apply the loading to it. So let's do the loading, dead load and live load. So let's assume this is a dead load and live load, and the later loading we put in the live load 2, and then the live load of this dead load is live load 1. So all the vertical loading on the chassis is going to be the dead load and live load 1 as well. So to do that one, what we need to do is that we need to create that. So let's click on wipe area, so that deselect all the things. Then after that, we possibly want to let me see how can I change the view of the display here. So let's maybe change the local system, local system grid line, and this is a 3D view, yes, but when the structural and the structural axis, so let's untick this one, the structural axis, and then click on apply. So this one going to disappear, so make it easy for you to view. Then what we need to do is just loading. So we go to the loads, and to create the that load, so we need to create the load type first. So let's click on add, and then you create one that load case in these structures, and then we need to define the new loadings, add on to this one, which is a bar loading, and then click on this one. And the that load we have is 20 kilonewton and per meter, so we put in negative 20 newton in here, and click on add. So the loading has been generated. So we need to apply this one to properly to this structure here. So we just need to simply let me just zoom in this one a little bit and enlarge this one a little bit. So what we need to do, we're going to put on here, so just one for first side and then that one for this bin, but just need to make sure when the bin is highlighted, you need to make sure this is the bin you're going to apply to after confirm. So before you press click, and then make sure you confirm this is the bin you're going to apply. So this one here, and then that's the one we haven't applied, and so this one has been added. So this one has been oh, let me check whether this one has been added or not by hold on the shift key and rotate this one a little bit. So it's better if you want to see this one, I can ask them to put on the loading to these structures. So let's have a look at this one. So to make it easier for us to view, maybe I just disabled section view, so you got this one directly and onto the structure here. So maybe the number won't help. So let's come in to have a look. So basically we have these three added already, so this one hasn't, so we add on this one, and then we add on this one as well. That's it. So for the one side, and then we're going to do the other side as well, but this time let's maybe make sure that we do that a bit wisely. We do one side from bottom to up, and then don't switch to the other one that quick. So let's do this one, second and third one, and then do this one, second and third one. So that's all the loading you have for that load. And then once we have finished that load, we need to apply the live load as well for this column. So let's do the same thing. So by changing this one to live load, and then click on add. And then once this one created, we need to create the loading. So the loading we have for this one is 30. So that's going to be negative 30 kilonewton, and then click on add, and then we are ready to apply. So make sure this window is highlighted, so we come back to this one. So you will see that we're going to apply the loading to the structures. So that's the one you're going to put on. 1, 2, 3. Oh, the 3 is not yet, so that's all. So 1, 2, 3. Okay, so that's the loading you have. So and then this one, and this one, and this one. So we put on this one, and this one, and this one as well. So now and we possibly made one mistake, is this one. this one should not have any loading. So let's come back, right click on this one and then delete it. So let's click on OK. So that one has been deleted, so which means this one hasn't been added yet. So we need to maybe pick up the loading to apply to that one. So that's -30. So that's okay. So we can just oh sorry, that's wrong. So let's come back to this one and then make sure this one is added already. So we can come back to apply this loading to this one directly. So that's what we need. Okay, so that's the loading you have to apply. So let's close all the windows. So just double check if you click on this one. So that's all you have, and this one, that's what you have for the live load 1. And then we need to create the live loads 2, which is connected to the later loading, say the win loading. Theoretically we should put in the win loading, but however it doesn't matter because we know that's one type of the loading. So let's click on this one, add to the load case 2. So the load case 2 is the later loading, so we need to create this one. This time is the point load only. So the point load is along the X direction, and then let's have a look at the loading. So you have that live load 100 kilonewton and half of it 50. So let's put in the X direction is 100. So for the top 2 story, so let's click on add, and then we need to maybe change this window to proper window to proper direction, so allow us to add this loading properly. So let's say this is the positive direction, so the positive direction along this direction, so we apply the loading to this node. So this one and this one and this one and this one. So the bottom top 2, so going to be 50 only, so we put in 50 and add to it. So let's put in here, here, here. So all the loadings has been applied. Then don't forget we have the top layer of the structures. We have each top node is carrying 20 kilonewton dead load and 20 kilonewton live load. So what we need to do is that we need to change this wheel to a proper direction, so we can choose this one easily. So just use this one and then change to maybe XZ. So that's maybe one of the best wheel. You can have a look. So you possibly want to zoom in this one a little bit. So what we need to do is that make sure you are in the select mode, and then make sure that is in that load case 1. So you choose all the nodes by select the first one and hold on the control key and select this one by one. So all the top node. So after that, what we need to do is that we need to define the loading. So this is one has been selected, define the loading, and then this is point load, and remember is the negative Z direction, so it is 20 kilonewton for that load. So let's have a look. It's 20 kilonewton for each that load. Okay, so let's put in -20, so that will be -20 downwards. So we click on add, and then so all the nodes is applied to this one, so you can just simply click on apply. So all the top node has this loading. Oh, this one is too much, so we don't need this one. So what we need to do is that for the last bit in here, so we possibly need to undo it. So undo it. And then once undooed, then oh gosh, redo. So redo already. So that's what you select here before you apply the loading. Then this one is need to deselect. So you need to hold on Control key and select this one again. So this one deselected already. So after that, you can click on apply. Oh, so possibly need to yeah, we need to generate this loading again as well. So make sure this one is selected, and then click on add again, and then this time click on add. So the loading is applied to this one, but this time this you don't have the loading in here. And so that's the point low. And then also we need to close this one and then change this one to live low, and that all the joy has been selected, has been highlighted at the moment. So we need to just need to create the nodes. The loading this time for that low, for live low, is 30 kilonewton. Change is 30 kilonewton, and then click on add, and then once you click on apply, so the loading for live low is closed, is applied to this one. So let's close this window. So after that, let's have a look at what we have. So this is that low. So this is that low, and this is live low you have, and that's the live low 2 you have. So we have now finished apply the loading to the structures, and then we have a look at the loadings that separately, that in different case already. So if you click on this one, that's showing that all the loadings we have in different low case. And to create the analysis, what we need to do is that we need to create a combination of it. So to do that, we need to use this function which called combinations. Just click on this one, and then we use the this pop-up window to define the different combination. Let's assume that combination 1 is the one that we set for the name of it. So for all the that low, we have 1.35 safety factors for this one, and then both of it, number 2 and 3, is going to be 1.5 the safety factors. So we click on this surveillance, and then you got all the combination is set up already. So once finished, you click on apply and then close the window. Then you can have that one combined loadings showing in here. So that gives you the combined effect of the entire loading we have applied to the structures. So once we finish this one, then what we can do is that we can actually have a look at the structures which we have in here. So to be safe, and then that's all the structures we have with all the loading and with all the combination. Now we can save it again as the step 1. So we can save this one again as a step 1, and we replace the previous file, and then which with the combined loading as well. So the next one, what we need to do is that we haven't linked them together yet. So what we need to do is that we come back to the original structures, and then we maybe move to a proper directions, allow us to see the both that surface that easily. So to link these two together, we need to use a special function which is called the compatible nodes. So compatible nodes which are going to link two nodes together. So with these two nodes, gosh, somebody call again, that's a miss. So sorry for the phone call. And what we're going to use the function which is called the compatible nodes to achieve this one. The compatible nodes, what that means is that they have two nodes in here. They are separate nodes, but however the compatible nodes can allow you to set up they link the displacement between these two in a certain degree. Like if you have x, y, and z displacements, they link these two together, so to tie up these two. So when this node is moving along this direction, and this node going to move together with it, so you can set up all these informations, and then you can that force these two they deform together. So how to do that one? We need to define. So the first thing, when you come to this one, you need to define the compatibilities. So we have one here at this moment. So let me just delete this one, delete this compatibility type, and then we create a new one. So we click on this one. So in these compatibilities, and then we can set up a compatibilities to link these three directions only, or if you prefer, you can set up one directions in a certain linear spring stiffness, and then you can apply to this one. But however, what we're going to do, the first step, we use these three, which is the that directly link them together, so without any relative stiffness connecting they two together. So once you satisfy with this three, just click on add, and then close this one. So you create a new compatibilities between these two. So once you set up these compatibilities, and then you need to manually apply these two nodes, which you need to set a node which is the main role. The other one is compatible nodes to that joint. So what you need to do is that, let's say we need to select the different joint, and then we need to notice that which joints which. So we can know that we want to set this one as a main role. A main node is a 256, yes, and here, and then the other one is 43, the other one is 43. So this is the suggested node, so we don't need that one. So once you set this one, you satisfied, and you click on apply. So that was the compatibility condition applied to these two joints. And also we can do this one for the next, the 251 and then 1. So we can put in here, so which is that the 251 and the link to the number 1, and then you can apply. So that's linked to this one. So when this node move in any direction, this joint going to follow. So once you set up this one, then we're going to maybe spin this one to the other direction, which allow us to see the both node clearly. So we do the same for the next. So this one is 118, this one is 63. So let's put in here 118. The other one is how much? 63. So that's 63 in here. So we can apply. And then the next one is 221 and 123. So we put in 123 and 21. Yeah, 21 in here, 21 in here. So then after that we click on apply. So these two nodes are now are linked together. So when these two join, so these two part of the structure, actually the moment since they are not that linked together at the same point, but however, because of the mathematic or mechanic the function we use here, they are mechanically linked together. So it is entire structure. You can see that in computer, in the structure not necessarily to link together physically, to connect together. As long as you use the proper model tools to link them together, you can run the analysis. So this is somehow like structures that one is flying in the air, the other one is on the bottom of it, and once you apply the loading this one, this truss going to open up, and then that go on open up because of compatibility problem. You set up the sort of compatibility relationship you set up between these two joints. This joint move and this joint will follow, and then that's as if these two are stitched together. So they are the same. So no matter you put them together or not put them together, they give you the same answer. So that's why you can run the analysis now. So you can click on this one and then run the analysis. So I expect there was nothing long with this system, so we can have a look at the displacements. So once you have a look at the displacements, we can maybe change to the front view. So this is front view, and then we can step the displacement by click on here, and then that's the displacement you have. So and then you can set it back, and we can also that maybe easier to change to the result, and then result view here, and then we can maybe set the deformation and take the deformation and can apply. So this is the structure. You see this deform, and then this they deform at the same time. So that's structures you can have, and then what we can have a look at it is that you can see how the structures deform together if you have live load only, and then you have that lateral loading. You see this loading transfer to here, and then this one through these structures, the loading apply here, they push this joint, the joint push this side, and that move together, and then the form through this truss, and then transfer the loading to the other direction. So but because the transfer through that one, they have a reduction to this one, so we have smaller value applied to these structures. It's quite interesting, right? So we have a look at the combination as well. So this is a combined effect you have with all the loading that applied, and then if you want to have a look at a 3D view, that's the structures 3D view we have. So interesting. And then let's maybe, if you want to carry on to have a look at the details of the actual force and the moments, and feel free to do so. But what we're going to do here is that okay, somebody still not comfortable that with the layout we have in here. So we can actually, if you don't happy about this one, so we can have a look at the structures. Say if you can have a look at this part, and oh gosh, I need to maybe come back to result, and then untick this one to make sure that this one not going to show both together. So what we can do is come back to the structural mode, start, and then say we can change the wheel to this one. So maybe you're not happy about the structure is that construct in this way, and what we can do is that we can possibly save this one at the step 2 that we give a name to step 2 direct connections, and direct connections that also not direct connection is that maybe let's say connection that the truss above. So we have a truss above, then we save this one, and then at step 2. So what we can do is that we can figure out how much the elevations we have in here. So there's structures. What we can have, we have the coordinates. The z coordinate is 33.54, and then here is 12 meters in this one. So you have 12 meters in this one. So the difference between this and this is 21.5. So you can select all this one, and then if you're not happy about this one, you still want to see the structure directly on top of this one, you can move this pin, and then you need to put in this 0.0 point that negative 21.5 meters. So you can execute this one, and then the whole structure is going to move down. And then whoa, where is that one? Oh, it's too much. So that's undo it back. So must be something wrong. I don't know what's wrong. So let me do it properly in here. So let's choose this one, and then again select the move edit, move and copy. So we move this one, so the distance is 0.0 negative 21.54. so that was the distance should be moved down. So let's click on execute. So that's it. So that's just directly on top of the structures. So if you want to see the 3D view, that's the 3D view you have. So that's the structure here. Okay, and then let's zoom in a little bit. Then we can actually run the analysis. So yes, and so if you want to have a look at the side view, that's the side view you have, and then we should be able to have a look at the deformation. So that's the deformation we have. So possibly if I disable this view, that's give you the structures deformation for that low and live low and live low too. So that's the structure deformation and the combined effect. Okay, so that's the structures for the both are acting together. So that's the whole structures you want to see. Let's try to analysis the further, which that I want to see the structures that is support in the x, so support in the y direction, and the z direction, but not the x direction. So x direction allow them to move freely from one end to another. So let's have a look at how can we achieve this one. That in these structures. So to do this one, basically what we need to do is that we need to make sure the structures in here, they are linked to one end but not the other. So to do this one, so we possibly need to put in one end is connected, so which we don't need to change in one end, but the other end we possibly need to change this one properly. So to do that one, what we need to do is that we better open up the model we already saved, which is step 1 we have set up already. And then we can maybe before we close this one, so we save this model. Let's come back to the starting point, and so this one to the original point. Then let's save this one as the direct connection step 2. So direct connection step 2. Save this one. Yes. And to achieve the next one, what we're going to do is that it's better we set up the connections between the structures, and then we can use the direct connection of the truss above the one we have set up for. So open this one. So within this model, what we have done is that we have set the special. Oh, just spin to the proper direction, which we can see this one easily. Okay. So that's the direction. So if we use the compatibility, one problem we have, we already get this tool compatibility problem set up for this one. As we said before, so we want to put rollers on this one, which allow this one to roll along this direction, and then only the y supported, z supported, but no x. So what we need to do is that we need to first thing is delete the compatibility. We don't need to do anything to this side, assume they're linked, but lower on the other side. So how can we do this one? How can we achieve this one? So to do this one, we need to delete the first one, the compatibility along this direction. So we delete this one, so they don't have this one anymore. So we click on this one, so don't have the compatible joints between these two and these two. So we need to set up a new compatible nodes for this one. So that's called compatibility number 2. So in this one, we link with Y, we link with Z, but not X. So we click on Add to this that action. So you get the 2 set up here. So now we assign this one to 256. So 256, and then we assign this to the 43, this node there, and apply. So that's only that link these two. And the other one is free. Okay, so same as this one, we link this one to the say how much this one, so it's 251. So let's use 251, and then the other one is number 1 in here. We just apply this one to this joint. Then we can have this roller apply. So now this one, between these two, we have this one. If this one dropped, this one dropped, this one going to follow. If this one move in this way, this joint going to move this way. But X direction, no. X direction, if this truss move in this direction, they're going to let it go, and then they don't move. So let's have a look at the behavior from this one. Let's close this one, and then if you run the analysis again, and then if you want to have a look at the front view for this one, you see the loading for this part. So the dead load, if you have a look at the displacement here, right? So the displacement, you see the dead load, vertical loading. So this one moved, this one not. Okay. So if you want to have a look at the top view, see that's the way, or maybe that's maybe easier ways to do that one. Maybe it's not to have a look at this one. Let's maybe go to see the result layout. Let's click on this one and then come to result. So we click on the deformation. Then if you click on the animations, you will see the how the structures is deformed. So oh, I think the friend, let's maybe stop this one. This not clearly showing. Let's click on deformation, apply. So that's the deformation you have. So once we start this one, let's see whether I can start. So you see this is deformation, you can see. Then you see this one, even you apply the loading, that low, and they only apply to this one, and then this one going to maybe move very small, slowly, you can see compared to this one, but you don't have any loading transfer between these two and this one, so they not move laterally, they only just transfer vertically. So if you have a live load, the live load going to be the same, so it has same effect in this one. So the structure here is vertically move very small deformation, and then the lateral load. So this is the lateral load. So let's maybe have a look at. Let's stop this one. Stop here. Yeah, stop here, and then you're going to see the deformation, but that's apply. Low case. This is combo. Let me have a look at the formation, and then we need to see the that load tool, and then click on apply. Oh, why is not coming back? So let's come back. This one apply. Oh, still not. What's wrong with this one? This one. We possibly need to close this one first. Yeah, close this one first. Then we change. So every time we need to change this one. Like close deformation, apply. So that's the lateral loading, the effect you have. So if you start the animation, you see the loading apply. and then the loading apply. So the whole structure, because there was a roller here, so they just move that complete together with this one, but not going to transfer any force to the other tower. So that's because of lateral loading. And this is the lateral loading. So let's close this one. And then we can change to the combo. So the combo that with all the loading together. So you will see that the structures in here, they move from here to here, and but of course that scale was too much. So let's maybe change this one to 1. Let's have a look at the too much. So maybe change to 500. Apply. Sorry, 500, and apply. So that's maybe still too much. Let's 1000 and apply. So that's a combined effect. So if you have a look at the animation, you see. So that's the effect. So you have a lateral loading, you have a vertical loading, but this one is a roller, so they have a roller effect. They not transfer any loading to this part. Okay, so let's close this one, and then undo the deformation, apply, come back to that starting point. So somebody maybe still prefer to have a look at how is this one connected to this part. So we can certainly move this down. So before we do that, so we can save this one to step 3. So step 3. So roller with the truss above. So with the truss above in here. Then what we're going to do for this one, we can just move all this one down. So now we have finished the truss structures on a roller, and then on top of the building. And we can see that we actually don't need to put these two structure together, and we can still run the analysis as long as we play the mechanic that the relationship correctly between the two joints using the compatible nodes. And then but somebody may insist to see that, look, I'm not happy about the way it looks. I still want to see that actually the structure connected together, and you can do so, and if you want, by moving all the structures down to the proper location. So let me show you how to do this one. So what you can do is that you can select all the trusses in here, and then you go to edit, and then select move and copy. Then what you need to do is that what we can do is that we can make sure this is clicked on move, and this time I'm going to demonstrate that how we can do that one easily, instead of picking up the inputting the distance in here. So what we can do is that we can move our cursors close to one joint. You see the cross that snapped to the corner joints of the truss. So let's click on here. So this one, then we drag down exactly to the next point where this truss should locate it to. So we can click on this one, and then of course if you're asking, because it's moved the structures, so you need to rerun the analysis. So are you okay to, do you want to continue? You need to click on yes and then continue. So the truss is located on top of the frame structure is ready. So once finished, then you possibly need to run the analysis. Be careful that they may give you a warning, because there was bars end of the trusses, and then the frame system, they are overlapping together. But for us should be okay. Let's just click on yes and then let it run the analysis. So once you finish the analysis, you possibly see that there was two locations. They have overlapping bars and the columns, but that's okay. Let's leave it on, and then we can maybe switch on to this direction, and we will be able to have a look at the deformation for different locates by using the result layout. So let's have a look at the result layout. So if you have a look at the deformation and then you can click on apply. So that shows you the demonstration of the structure. You see the truss is moving, and then but the top of the bar rolls through the top of the frame system, the multiple story building, so they release all the loadings there in between. So this is the lateral loading. You see that so this is the live loading, and then you see the lateral loading here. So that's only this part is moving, and this moves very little to the other side. So the mainly this should be the lateral load too. So this is moved very little. So major deformation occurs in these directions as well. So that's what we have the moment for the structures, and then possibly somebody want to see the combine. So let's have a look at combine. So this is the combine effect. If you want to start the animation, you can see how the structure moved. Okay. So possibly enough. Then let's stop this one and then close this window, and then back to the structure mode. So that starts in here. Then what we can do is for these structures, what we can do is that we can say, close this one. I can maybe, I need to maybe disable the displacement, otherwise it looks quite confusing. Let's close this one. So what I can do is that I need to come back to this one, structural mode. Then I save this file and as a roller on top, and then save it, and then yes, and replace. This is the new model. And the last thing I want to do is that I want to show you how we actually can do the a competitive node, but actually we put the a sprint into this connection, which means in horizontal direction, and these two are not free, so there's not free movements, but instead we put the sprint in between, so that allow the whole structures move laterally. That and then you can control the sprint then to control the displacements of the both structures. So that possibly maybe one of the most common things that you can use. If you want to stiffer one, then put a larger stiffness length in between them, and if you want to have a weak one, you can put a small stiffness into the spring. So let me see how to do that. Let's have a look at how we do that one. So let's close this project, and then let's open the previous project we have set up. It is a roller above this one. So the moment we set up one side and one side of it, and then it is that the fixed support and then x all this one is x, y, z, and then move together. This one is y, z move together, but along the x direction it's been released. So what we can do for the other one for the spring connection between this joint and this joint. So what we can do is that we can close this window and then bring up the structural structural detailing in here, structural definition in here. So what we can do is that oh, that's too much. Maybe 2 will be easier. So we can use the compatible nodes at this time. Let's delete what we have before. So to delete this one, it's difficult to see. So what we can do is that bring this one back by click on this one. So you see this is the compatible relationship you set up between these two joints. So let's click on this one, and then we delete all, and delete the second, and delete this one, and delete this one. So now what we're going to do is we create a new somebody that asked the information, so forget it. Let's put in this one. So we create a compatibility relationship of the third case, but this time what we can do is that and we set up this elastic one. So what we're going to do is that we block this relationship along the ux oh sorry, not this one. So and then we block these two, so in YZ direction they are moved together, and then the other things, the UY and U sorry, not U, the X direction. So we can put in say for example that big numbers, and here say for example we set up this one, and the spring stiffness is the 100 kilonewton a meter, or possibly a meter, probably too small, so maybe put in that 100,000 kilonewton per meter this loading to these structures. Then after that you click on add. So you see this tool, they will create a fixed support, which is horizontal, vertical, and then horizontal in Y direction. But however, the X direction is that spring stiffness, which have 100,000 kilonewton per meter. That spring stiffness has been assigned to that direction. Then we can click on add to this one. So once we have this one, what we need to do is that we need to assign this one to this structure. So we need to click on one of them. Then we maybe possibly need to change this one to the what is the other node? So 43. So 43 apply. Oh, hasn't been signed off, so this is possibly not a good way to do. So let's maybe click on this one and then just click on this one to delete it. So let's do it again. Compatible 3. So let's 256. So that will be 256. And that one 43, so 43. So we manually apply, so that's going to link together. And then the next one, so with 251, so 251 compatible 2. The second one is number 1, and then apply to this one. And so for this one, so 118 118 compatible to the 63, so we put in 63 and then apply. And so this one 123 and compatible to 21, so 21 and apply. So that's all set up already. Then we can start to run the analysis to see the result by click on the run the analysis, calculate. And then after that what we can do is we can show the wheel by click on this one and open this window and change to the result wheel. And so deformation, click on this one, let's choose deformation 1. You see then they evenly distribute these two structures. And then so you see that the two are not moving at the same point. They're moving maybe that's slightly different. They have a spring connecting to this one. So if you have a lateral load, which we have before, there was a very small movements transfer to this part of structures, but this time he can transfer some of them to the other one. So let's maybe put in the scale to a smaller one. You possibly see easily. Not enough, so let's put in 100. So you see they are transferred, they did move to the other direction. Okay, so this is the spring inside the transfer the loading from one to another. Then you can define the other stronger spring, which maybe to give it transfer more loading to another one. So that combination, so that's the combination of the whole structures. And then if you maybe change this one a little bit bigger to 500 and apply, so possibly that's a better way, so you can see the animation if you want. So that's the loading you apply. Okay, so you can move this down to this on top of the structures if you want, or possibly we can do this one together. So we maybe try the last task. Just stop this one, close, and then come back to structural mode, start, and forgot to do that one again. So let's come back to start and disable this one, apply, then that's original structures. So if you want, and then we maybe better save this one as that not roller, this spring and truss above. Okay, let's save this step 4 as step 4 and then save it. Okay, then what we have now, so that's string above, we want to move this one down. So what we can do is that we need to do it again like what we did before, copy this one, and then when it asks the deformation, we use edit and move, and then we just select the point from here that's moved down to the corner here. Oh, I forgot to tick this one. Let's undo it. Let's do it again. So change this move, and then with that there's a mistake there. So press ESC key to to move out this one. So let's close this one first. And let's maybe to back to the select mode. Just select this first, and come back to the edit, and then move. So what we can do is that make sure this time is move, not copy, and then target this point and move down to this one here, and that's it. So that's all the structures you have. So of course that you possibly need to run the analysis again to get the result, so you can run the analysis just carefully. So overlapping again, so that's fine. So let's close this one, then we can close this one and then have a look at deformation. Yeah, so that's click on apply. Oh, deformation here, close. So that's the structures we have. And can we see lecture 2? So the structure is pretty strong, right? So that's why we can't see the relative movements between the two. So possibly the let me have a look. So let's have a look at this one. Nature 2, yes, and then yeah. Oh, they are moving at, so can't see much difference in here. Yes, you see that's difference between these two. So possibly if we have time, so let's maybe do it a little bit more. Say for example, if you change the let's come back to this one. If we change to compatibility problem we have in the structure definition here, let's bring back this one. So let's maybe change this one, compatibility that information. So if you double click on this one, so we change this one to a little bit smaller value, so put a weaker, so that maybe 10 times, maybe too weak, maybe that 10 times less than this one. So we can that modify it. Yes, modify this one. Then so we close this one. So this one change to a smaller value, and then we run the analysis. So then possibly you can see the difference between these two a bit better. So let's close this window, close all this one. Then under the that low, so you possibly can see some difference a bit clearer here. So that's the truss where it moved to, and that's the original structures. So they did have a relative movements between this one. If you put the spring in between, so they are not a roller, they are not free, and then they're not rigid, they not move together as well. They have a spring link between them. So that's transfer the loading between them. Okay, so this is I guess that all the trainings we have for these Truss and frame structures. Hopefully you have enjoyed, and then I'm going to maybe close down this one. Then if you have time, you can come in to have a look at more these videos yourself in your spare time, and then do some modification to the structures, and then if you model more complicated along this direction, so feel free to do so. So that's it. So hope you enjoyed. Bye bye.